Today we're going to find the area between two curves. So rather than looking at just the area under one curve, we can find the area between two curves. So let's say we wanted to calculate this area between f of x and g of x, and that we're looking from A to B, that's where they intersect. We can do this by finding the area underneath f of x. So that would be the entire area underneath the pink here. And then we can subtract out the area underneath g of x. So that's what the area would look like, and we can simplify this and say that the area between these two curves is equal to this. So let's start off with f of x quadratic, and let's go with g of x as linear. And we're just going to look at the area on this interval from 0 to 1. So what does this look like? We've got we start with f of x. F of 0 will be equal to 2. And then f of 1 is equal to 3. So we're just looking at this quadratic function from 0 to 1, that's what it looks like. And then g of x is equal to negative x. So g of 0 is 0, but then g of 1 is equal to negative 1. And that's linear. So we are looking at the area between f of x and g of x. Now notice this graph here goes below the x-axis. That really doesn't matter any, because we can consider this area as the sum of the areas of infinitely many rectangles. So whether or not g of x is below the x-axis doesn't matter, because we can still find the heights of these rectangles by subtracting f of x minus g of x, right? Top minus bottom. So our area is equal to, we're going to go f of x minus g of x. So it's x squared plus x plus 2. If we substitute 0, all of these terms will be 0. And so we get 5 halves, or 5/6, plus 2, which is 17/6. So the area between f of x and g of x on this interval from 0 to 1 is exactly equal to 17/6.